Welcome to Autodesk Revit 2022. At this point, I'm going to discuss the ribbons, tabs, panels, and its purpose. The ribbon is the primary interface component for accessing the various tools and functions in Revit. These are the ribbons. The ribbon is organized into tabs, with each tabs containing sets of related tools arranged into panels. Each ribbon contains a group of panels. These are the panels. And inside these panels are individual tools that can be used by clicking on the desired tool. For the Architecture tab, you will see the Build panel that includes many of the most frequently used modeling tools for creating architecture. For the Insert tab, you can see the panel names, Link, Import, and Load from Library. For the Structure tab, you can see the panel connections and reinforcement. Each tab contains different panels containing groups of related commands. Going back to Architecture tab, within the panels, you'll find three types of tools. Some buttons like the window tools, it activates a specific tool. And a split button like the wall tool, it is the most used at the top with a drop-down button which displays additional related tools. And for the column tool, it will switch between the default and alternate tools. The most frequently used tool is displayed on the button. You must click on the drop-down to expand the list and see the tool you wish to use. Some panels include a small triangle next to the panel name, and if you click the panel bar, the panel expands to show additional tools. And for the Annotate tab, when you use some tools, such as text, notice that the ribbon changes to show a different set of tools for creating and formatting text. This is called Contextual Ribbon because it displays tools that relate only to the context of the tool or element you are creating. There are several ways to control the display of the ribbon. The ribbon state button on the rightmost end of the ribbon lets us toggle to 3 ribbon display. This one. If I click this button once, the ribbon is reduced to tabs with each ribbon panel represented as a single button. If I move the cursor over one of these buttons, the particular panel expands to display all of its tools. And if I move my cursor away from the panel, it collapses back to show just the tabs and panel buttons. And if I click this button again, the ribbon is reduced even more. Now, the ribbon is reduced to tabs and ribbons panel names. And again, if I move my cursor over a panel name in that particular panel, it expands to display all of its tools. When I move the cursor away from the panel, it collapses back to show just the tabs and panel names. And if I click this button again, the ribbon is reduced completely. Now the ribbon shows only the names of the tabs. I can click on an individual tab to display its full ribbon tab. Like that. And as soon as I move the cursor away from the ribbon reduces back to just the tab names. And if I click this button again, the ribbon is restored back to the full ribbon. Notice that I can also click on the small arrow on the right of this button to display a shortcut menu. Here I can choose to minimize to tabs, minimize to panel titles, or minimize to panel buttons. If I enable one of these options, then clicking the ribbon state button toggles just between the full ribbon and the selected minimized ribbon. If I choose cycle through all, Revit architecture reverts back to its default behavior for cycling through each ribbon state when I click the ribbon state button. Within any ribbon, you can click and drag a panel to relocate it within the ribbon. Like that. And you can also click and drag a panel off the ribbon into the drawing area outside the application window. When you drag a panel off the ribbon, it will remain visible and its tools will remain available even if you switch to a different ribbon. To return the panel to the ribbon, hover the cursor over the panel until you see the sidebars and then click the Return Panels to Ribbon in the upper right corner. This will return the panel to the proper ribbon and to the ribbon location it came from, even if that ribbon is not currently visible.
To better understand how the software works, we will dive right into the simulation. After opening the software, we will be greeted by this interface. To create a new project, click New, and a window will prompt. And as we can see, there are different templates that we can use depending on the purpose of our project. But for this simulation, we will use architectural template and click OK. This is the architectural template working area. This is where we will draw our project. At the top is the ribbon. There, we will find all the tools needed for us to complete our drawings. It is divided in different categories and organized by tabs. At the left side, there are located these two windows by default. The one below is the project browser. This is where we can choose what view we want to see on the main window. Unlike other software we used to work with, in the project browser, we can actually see all the different views. And as we work with the floor plan, the software automatically generates all these different views and we can use this view in the designing of our project. On the top side is the property windows. It basically shows the properties of the current active element. In the maneuvering of the mouse in the workspace, it is the same as AutoCAD. To formally start our project, if you want to change the units, just click Manage and click Project Units, and then click Length. You can see the different units that we can use in creating our project. But for this simulation, I will be using millimeters, and then click OK. In applying walls, just click Architecture and then click Wall. And we can see in the property window the different type of walls that we can use. For this project, I will be using this wall, and then I will edit its width to 150. But this wall is already set to 150 width, so I'll just click OK, then apply, then OK. For the location line, choose wall center line. I will explaining for a bit about this location line because it has some important details to be discussed. So click wall center line and then apply. And don't forget to change the elevation of the walls. I will be setting the elevation into 3000 mm. And then we will start with our project. After completing the outer walls, we will move into the interior walls. Just select the wall that we want to use for the project. For the simulation, I will be using this wall partition and then change the location line to finish face exterior and then apply. The difference of the location line is the reference point where the line will be created. Like for example, the wall center line that we use in our exterior wall. When we connect another wall to it, it will connect in the center part of the wall. And for the finished face exterior, we want the wall to connect in the corners to avoid overlapping of the wall. So just click the point and then continue doing our project. For the elevation of the interior wall, it's not yet set. So we will just click the 3D view in the project browser and double click the 3D to create a tab for the 3D view. So as we can see in the 3D view, the interior wall is not, the elevation of the interior wall is not the same as the exterior wall. So all we are going to do is to double click the elevation of the interior wall and change it into 3000. And as we can see, it is already the same as the outer wall. So we will just go back in the floor plan and continue making our project. And for the floor, just click architecture again and then click floor. This window will appear. I will be choosing architectural floors and choose the rectangle option to select the boundaries of the walls. Start to this point and then move to this point. So in the property window, we can choose the floor that we want to use, but for me, I will be using this concrete floor. And don't forget to click this check mark here to apply our floor. If you want to check if the floors are properly installed, we will just click in the 3D view tab and we can immediately see if the floors are indeed properly installed. So we will go back in the floor plan and we will insert our doors and windows. For our doors and windows, Revit provides a very intuitive option to insert doors and windows. Those icons are located at the architecture and then click doors. And like any other elements that we previously used, we can change the properties depending on what we want to use. So I will be using this one and then apply it to the designated area of our project. So for the windows, it's just like applying doors. So just click architecture and click windows and we can choose on the dimension of the windows depending on what we want to use. So I will be using this and then place it in our project. After inserting the windows, we will notice this sill height that is prompting in the property window. This sill height is the distance from the bottom of the window to the ground. We can go into the properties of windows and adjust it in your liking. So for me, I will just stick to the default, which is the 1200 mm. After setting our doors and window, we will be moving on to our next and final element for our project, which is the roof. So we can find the roof in the architectural tab and just select it. We will be setting the roof height for our project into level 1 and click yes. Now in here, we can add overhangs to our roof. So I will be using 500 mm overhangs for our project, and then click boundary line for us to determine the boundaries of our roof, and then click the side of the walls, and as we can see, there is these two lines that are not connected. So just click modify and trim extend to corners, and then click the two lines that we are going to connect, and as we can see, the two lines are already connected. Now click the finish edit mode and then click attach. Click on the 3D views, and as we can see, we're done with our project.